So my name is Alexander Kozlov. I'm CTO at CloudBEAR, and I will present you about our RISC-V processor IP product line. In our portfolio, we have three series of cores for different target applications. BM series targets small and efficient MCU core. So we have two cores here. BM310, which is a 32-bit microcontroller core, and BM610, which is 64-bit and more focused on management cores in large SoC. BR series are fast and compact embedded cores. It's BR351 and BR651. So these are dual issue 9-stage pipeline cores, which quite compact, but can be clocked above 1.2 gigahertz and 28 nanometer and deliver performance for offloading the tasks from the main CPUs in the SoC. And Linux-capable application cores. So we have three cores for different range of performance. We have small core BM350, and we have a dual issue in order core BI651, and our highest performance to the day core BI671. So I will start with the BM series. So currently BM series cores is quite full-featured microcontrollers. So it supports all standard extension like IMC AFD, but also it supports new coming extensions. So this year we already support bit manipulation extension and cryptographical extension. It's highly configurable, so you can adjust the pipeline depending on your need from 2 to 4 stages. You can configure the ports to different protocols like XI4 or HB Lite. You can add instruction cache if you need TCMs of different size. You can optionally include dynamic branch prediction if you talk about the 4-stage version, where we need to compensate the branch penalty. And you can configure interrupt controllers and features of debug models. And our one new feature which we added this year, we added support of Nexus Trace and tested it with ER Workbench. So from a performance level, it's leading performance RISC-V microcontroller to the day. I think we have 1.83 on Drystone and 3.91 for CoreMark for 32-bit version, and according to MBench IoT, it is 1.21 faster than Cortex M4. So it's 21% faster than Cortex M4. And for 64-bit version BM610, it's about 38% faster. So some examples which we got at the customers, and I would like to share them with you. One example is about a year ago, we got samples with our customers of microcontroller for smart metering devices featured by our BM310 core. And now this chip already was deployed at the customer sites. They make devices based on it, and now it started shipping mass production already. We are supporting wide set of development environments. So we provide customers our own build of Eclipse IDE, which you can use for development, but you can also could use third-party commercial vendors for debugging and writing your code. So for example, you can use Lauterbach, you can use Ziegler, and you can use YAR, because all of these companies, we have interoperability tests. from this year, we implemented Nexus Trace in this core and make it available, and we tested with ER systems. Regarding the applications of BM310 core, it's quite useful to use it in one example, which I would like to share as a housekeeper and security boot processor. Since it already supports K extension, it can increase speed of booting process in a large SoCs. So at the start of it's a power up, this core can take the control and check the firmware which the SoC boots and can be used as a root of trust for whole SoC. And after the booting process, this processor can manage the power, manage the system, and it's also, since it's 64-bit, can address full physical address range of the chip. So it's quite comfortable and useful to add this microcontroller to the large SoC. BR series, like I explained, it's a dual issue, 9-stage pipeline, also quite heavy featured microcontroller, can be clocked at 1.2 and 28 nanometer and have a competitive performance level with other vendors. Regarding BI series, I will stop today on BI 671, which is our flagship core, and other cores you can refer in other presentations and our website. And currently, this core is a mid-range application core, which provide good level of performance and can be used as a replacement of such cores like A53, A55, and give you additional 50% of performance comparing to A53, while still it's quite low power, and comparing to heavy cores, it's a low area core, which is because it's two-way superscalar, but anyway, it can achieve 75 to 80% of performance of four-way RISC-V superscalars. Note that this year we also add two features with extensions to the core. So it's also support bit manipulation extension and cryptographical extension, which made it quite useful for networking, for performing secure connection to the cloud, use it as a IoT gateway, or use the cores in the VPN devices. So we support multi-core configuration, and you can get with our IP fully integrated Coreplex subsystem, which will include L2 cache, debug modules, interrupt controllers, and coherency controllers for integrating with other peripheral devices and accelerators. Example of application of these CPUs are shown here. It's a project with our customer Melander. It's planned to be tape out at Q2 next year. So it includes two BI 671 autophoto cores, and will be clocked and 1 gigahertz at WASC additional silicon. Note that this project is on 40 nanometer. Also, we have sub-boot and real-time subsystem, which based in BR351 core. It's provide you security functions and can offload the work of devices which require deterministic response and real-time operation. Besides that, chip will have quite a lot of peripheral devices. It will be NVDLA accelerator. It will be PCIe, Ethernet, LCD controllers, MMC. So it will be quite useful RISC-V device available next year. So thank you for your attention. Please join us at Twitter and visit our website to learn about the details. Thank you for your attention.
Thank you very much. So, any question? Question. Sorry. I got a question from audience for CloudBEAR. How do you implement the trace interface to connect to the IAR debugger? Is that the same as SWD or TPIU, like ARM trace interface?
Yes, good question. So at the output of the core, we have ingress trace interface, which is standardized, and we have own trace encoder implementation, which encodes the stream, and then we have two options currently supported. You can use SRAM as a sink and download it then via JTAG, or you can use PIP interface, which is a 4-bit bus clocked at dual edge clocking, and ER probes are supported, so it was tested with ER, and then it directly goes to the EDE, right, to the ER EDE. Currently, interoperability testing of this, and this is support Nexus standard, right? So currently, interoperability tests were done only with ER-EDE, but we plan to do it with others, guys.
Okay, thank you very much. So, is there any question from audience? So I have a question. So CloudBEAR has a very wide range of IP core. So what is performance in core mark or spec in?
Yeah, I have shown that on the slide. So if we talk about high performance Linux capable core BI671, core mark is 5.6 per megahertz. And spec in is about 5.5, depend on configuration and how you clock layer 1 and layer 2 caches. So we have two options. We have option to clock the L2 at the half of a frequency of L1, and you can clock it at the same frequency. Same frequency is about 15% faster.
Thank you very much. Is there any question from audience? So waiting question. So still we have time. So please submit question to CloudBEAR. Another question from audience. So about Linux processor tape out Q2 2022. So which OS is fastly to implement? Is there some candidate?
Sorry, could you repeat, please?
Yes. Regarding Linux processor, target tape out is 2022 second quarter. Which OS
Yeah.
is fastly to implement?
Operation system, you mean?
Yeah.
Yeah, so it's a Linux based. It's Linux based. Yeah, so it supports normal Linux distribution which support RISC-V. Internally, at the company, we tested the various distributions. So we tested Debian, we tested Fedora. So yeah, it's supported.
Okay, thank you very much. Okay, thank you very much. Thank you for your presentation.
Thank you.